Assalamualaikum warahmatullahi wabarakatuh. My name is Anik Rafiuddin Shah bin Muhammad Anwar and my metric number is 2024248014. Today, me and my group will discuss about classification of polymer. Before we jump into the topic, we need to know what is polymer. Polymer is a substance made up of long, repeated chains of molecules that are produced by living organisms. These materials are all around us and have been used by humans for thousands of years. Okay, now I would like to share a few examples and explain how natural polymers can be classified based on their sources. First, we have natural rubber, which come from the latex of rubber trees. It's highly valued for its elasticity and is widely used in everyday products like tires, gloves, and shoes. Next is shellac, a resin secreted by the lac-bug found in India and Thailand. Shellac has long been used as a natural varnish, sealant, and wood primer, especially in furniture and musical instruments. Finally, there's cellulose, the most abundant natural polymer on Earth. It's found in the cell walls of plants and is the key ingredient in paper, textile, and even biodegradable plastic-like materials such as cellophane. These polymers come from both plant and animal sources, and because they are biodegradable and renewable, they play an important role in promoting sustainability. By understanding where these natural polymer come from, we can appreciate their value and make better choices in the future. Okay, now let's talk about synthetic polymer, which are quite different from the natural ones because synthetic polymers are engineered in laboratories. They are created through chemical processes that allow scientists to design materials with specific properties such as highly strength, flexibility, or resistant to heat, water, and chemicals. One of the most widely used synthetic polymers is polyethylene. It's the plastic found in shopping bags, containers, water bottles, and plastic wraps. Polyethylene is lightweight, affordable to manufacture, and extremely durable, making it a top choice in the packaging industry worldwide. Another common example is polystyrene, often used in the form of styrofoam. You will see it in disposable cups, food trays, and thermal containers. Thanks to its insulating abilities, polystyrene is also used in building insulation materials. In packaging, it's often molded into custom shapes to protect fragile products like electronics, appliances, and glassware during shipping. While synthetic polymers offer clear advantages, including durability, versatility, and affordability, they also pose major environmental challenges. Most are non-biodegradable, meaning they don't break down naturally. This has led to increased effort in recycling technologies and the search for more sustainable, biodegradable alternatives. By understanding polymers through the lens of their sources, helps us not only classify them but also make informed choices about how we use and manage them in daily life.
Assalamualaikum. My name is Muhammad Faris Haziq bin Muhammad Izzat Uzairi and my metric number is 2024668192. Today I'm going to present about classification of polymer based on structure. First of all, we have a linear polymer. Structure of linear polymer is composed of long, continuous chains of monomer units connected end to end without branches. The properties is we can pack closely together, exhibit high density and often high crystallinity. Other than that, tend to have good tensile strength and melting points. For example, polyethylene HDPE used in containers and piping, polyvinyl chloride PVC used in construction materials, and nylon used in textiles and engineering plastic. The second one is branched polymer. The structure of branched polymer is we have side change of branches attached to the main polymer backbone. The properties is less compact packing compared to linear polymers, lower density and crystallinity, often more flexible and softer materials. For example, low density polyethylene LDPE used in plastic bags and films. Amyloperidine, a branched component of starch. The third one is cross-linked polymer. The structure of cross-linked polymer is the polymer chains are interconnected by covalent bonds, forming a three-dimensional network. And the properties is rigid and tough, heat resistant and insoluble in solvent, cannot be remilled or reshaped once set, thermosetting behavior. The example is bakelite used in electrical insulation, vulcanized rubber used in tires and footwear, melamine formaldehyde used in kitchenware and laminates. So the fourth one is leather polymer. The structure of leather polymer is two polymer chains are connected at regular intervals, forming a double standard leather structure. The properties is extremely rigid and thermally stable, often resistant to chemical attack, difficult to process due to stiffness. The example is certain polycellulases and polyphenolanes used in high temperature or chemically harsh environment. And lastly is network polymer. The structure of network polymer is highly cross-linked to form an extensive three-dimensional network through the material. Properties: it is very hard, infusible and brittle. Excellent dimensional and thermal stability, and it is cannot be reshaped after setting. For example is epoxy resins used in adhesive and coatings. Phenol formaldehyde resins also used in molding and electrical component. Okay, now I'm going to presenting about classification of polymer based on polymerization process. We have two types of process, which is addition polymers, change growth polymerization, and condensation polymers, step growth polymerization. I'm going to talk about addition polymers first. The addition polymers change growth polymerization are a type of polymer formed when monomers with double bonds, usually alkalines, add together without the loss of any small molecules. The process occurs through a chain reaction and is commonly used to produce plastic. It is made from alkene monomers. No byproducts are formed, requires initiator, forms long chain of repeating units. And the process step is initiation. A free radical or catalyst break the double bond of the monomers. Propagation. The reactive molecule add more monomers and by one, creating a long chain. And the third one is termination. The growing chain stop when the two chains end with combine or when the active end is neutralized. So the next one is condensation polymers. Condensation polymerization is a process in which monomers with two functional groups forming polymers and small byproducts like water or HCl. Monomers have two functional groups, which is small molecules like H2O or HCl is eliminated during each step. Polymer built step by step and not by chain reaction, usually form polyester, polymerides, and proteins. The process step is bifunctional monomers. Each step produces a small molecule Reaction occur between any two monomers or oligomers. And the last one is polymers form gradually, needing high conversion for high molecule weight. So that is all from me.
For this part, I would like to explain about the classification of intermolecular and environmental classification. Intermolecular force are the force of attraction or repulsion that act between neighboring molecules, atoms, or ions. While they are significantly weaker than intramolecular force, which hold atoms together within a molecule. They are vital in determining the physical behavior of substance, especially in the liquid or solid states. These forces influence properties such as boiling and melting points, viscosity, vapor pressure, surface tension, and solubility. There are several types of intermolecular force, each with different strengths and characteristics. London dispersion force are present in all substances, but they are the only type of intermolecular force in nonpolar molecules. They arise due to temporary shift in the electron cloud, creating instantaneous dipoles that attract neighboring molecules. Dipole-dipole interactions exist between polar molecules where the partially positive end of one molecule is attracted to the partially negative end of another. A special, stronger type of dipole-dipole interaction is hydrogen bonding, which occurs when hydrogen is covalently bonded in highly electronegative elements like fluorine, oxygen, or nitrogen. These bonds are especially important in water, proteins, and DNA, where they contribute to the structure and stability of biological molecules. The strongest intermolecular force is the ion dipole force, which occurs between an ion and a polar molecule, such as when salt dissolves in water. These intermolecular interactions, although weaker than covalent or ionic bonds, are essential for many processes in nature and technology, including condensation, evaporation, protein folding, and drug delivery. The classification of environment can be broadly categorized into three main types: physical environment, biological environment, and human environment. Each category represents different aspects of the world around us and how they interact to support life and development. First, the physical environment refers to all non-living abiotic components of nature. It is further divided into three major systems: the atmosphere, which includes the layers of gases surrounding the Earth and is essential for climate, weather, and breathing air. The lithosphere, which consists of the Earth, crust, or solid land where we build homes, grow crops, and extract minerals. The hydrosphere, which includes all water bodies such as oceans, rivers, lakes, and groundwater, and plays a vital role in regulating temperature and supporting aquatic life. The second one, the biological environment includes all living biotic components of the earth. This environment is composed of flora, meaning all type of plant life that provide oxygen, food, and habitats. Fauna, which includes all animal species, both wild and domestic. Microbes, which are microscopic organisms like bacteria and fungi that play key roles in decomposition and nutrient cycling. Man, who is also part of the biological environment and plays a unique role in shaping and altering ecosystem. The third one, the human environment, also known as the anthropogenic or socio-cultural environment, includes all elements created, influenced, or modified by humans. This category is divided into society, referring to social structures, communities, and relationships. Economy, which includes all economic activities, industries, and systems that support livelihoods and growth. Culture, which reflects language, beliefs, traditions, knowledge, and practice passed down through generation.
Okay, my name is Muhammad Radhi Razik bin Shanuziat. My matrix number 2024641932. Okay, so we are going to describe about polymers types on application. Okay. So first, I want to explain about polymers. Okay, polymers are large molecules made up of polypeptide smaller unit called monomers. Because they are lightweight, versatile, and often strong, polymers are used in many fields of daily life and industry. Here are some important applications. So first, we have polyethylene, PE. So basically, PE we use in plastic bags, bottles, containers, and pipes. Next, we have starch-based polymers, basically used in compostable bags and food packaging. Next, we have natural rubber. So basically, natural rubber used in tires, footwear, and seals. The last one, we have polyvinyl chloride, PVC. So basically, PVC we use in pipes, cable insulation, flooring, and medical tubing. Okay. So in summary, polymers have become essential materials because of their versatility, cost effectiveness, and useful properties. From everyday objects to high-tech application, polymers play a crucial role in modern life. Okay, after explanation all about polymers, next we are going to conclusion polymer. Okay, polymer are versatile materials that play a crucial role in modern life, found in everything from packaging and construction to electronics, healthcare, and textiles. There are a wide range of properties such as flexibility, durability, lightweight, and resistant to chemicals make them suitable for various applications. They are generally classified into thermoplastics, thermosets, elastomers, and biodegradable polymers, each serving specific industrial and everyday needs. As technology advances, sustainable and biodegradable polymers are becoming more important to address environmental concerns. In summary, polymers are essential to innovation, and their responsible use and recycle are key to balancing functionality and sustainability. Okay, that's all from us. Thank you.